We're going to evaluate the integral of sine of square root of x. First, we'll make a substitution to make computations easier. We're going to let y equal to square root of x. We square both sides. Y squared equals x, and therefore dx is equal to 2y dy. We can now replace x with y, and our integral looks like this. Sine, what used to be square root of x, is now sine of y, and dx is replaced with 2y dy. And now we're going to use integration by parts. Recall integration by parts formula. The integral of u dv is equal to u times v minus the integral of v du. So the integral we're trying to evaluate in variable y, we're going to call the integral of u dv. And we have to decide what is u and what is dv. Now, we encounter problems like this before when we have a function such as sine or cosine and multiplied by a polynomial. In this case, polynomial is 2y. It's of degree 1. We always let u be the polynomial part, that is 2y, and let dv be the trigonometric part, which is sine of y dy. From here, we can easily compute both du and v. So du is equal to 2 times dy, and v equals minus cosine of y. So let's return to the integral. It was the integral of sine of y times 2y dy, and that's equal to u times v, which is minus 2y times cosine of y, minus the integral of v du. But notice that v has a minus in front of the cosine, so that will turn the minus in the formula to a plus twice the integral of cosine y dy, which can be easily evaluated again. So this is the integral of sine of y times 2y dy equals to minus 2y cosine of y, and then plus 2 times sine of y, and we can add a constant of integration c. This answer is in variable y. Our original integral was in variable x, so let's return to that. We wanted to evaluate the integral of sine of square root of x dx. Since y was equal to square root of x, the answer now looks like this: minus 2 times square root of x times cosine of square root of x plus 2 times sine of square root of x plus c. And that's the final answer.